This video is about the complete introduction to the EasyEDA course. So in this video we will see one by one all the steps that are going to be explained in the complete EasyEDA course. It basically explains the GUI of the EasyEDA software. I mean the graphical user interface of EasyEDA software. After that, it will explain the designing of schematics from scratch in the EasyEDA software, like how we can design any schematic that we want to fabricate and that we want to send to the manufacturer for the Java files. And it will also explain the designing of the PCB layout. So the first step is to design the schematics, make the connections of the components with each other, and the next step is to place those components in the PCB layout, and the other step is to route those components according to their connections of the schematic. So in this course we will learn how we do the designing of the PCB layout, how we do the placement, how we do the routing, and after that we'll also learn the main difference between the through-hole and SMD components. Basically the components that have pins and pads that go through the PCB to the other side of the board are known as the basically through-hole components, and the components that are mounted on the surface of the PCB, that surface can be the top layer of the PCB or just the bottom layer of the PCB. So those components are known as the surface mount components. So in this course we will learn the difference between the through-hole and SMD components. Sometimes we will use the through-hole components and sometimes we will use the SMD components. It totally depends upon the requirements. If we don't have the size constraints of the PCB, and if we don't need to worry about the fitment of the PCB in mechanical, then we just use the through-hole components. And if we have the specific requirement about the size of the PCB, that the PCB is now, for example, the PCB is supposed to fit in any kind of enclosure or any kind of mechanical, then we make sure that our components are SMD so that they don't contain much space in the PCB layout, and then we choose the SMD components. Fifthly, we will also learn about the generation of Java files. Those are basically the files that we send to the fabricator for the production of our PCBs. And we will learn about the generation of bill of material. Bill of material basically consists of all the components that we have used in the schematic. It contains basically from a resistor, capacitor, inductor, up to any IC of any number of pins. So it contains each and every components that we have used in the schematics and the PCB layout. We will also learn about the layers of the PCB. Again, the layers of the PCB depend upon the applications of the PCB. For example, if the PCB contains a lot of schematic components, eventually it will contain a lot of PCB components. And if we have an application in which we want to fit the PCB in a specific enclosure, then we'll make sure to have an extra layer or layers in the PCB so that we do the routing of the PCB more easily in EasyEDA. But if we don't have any like size constraints of the PCB, then we don't bother about the layers of the PCB. And lastly, we will learn about the data sheets, like how we read the data sheets of the components and how we collect the useful information from the data sheets of the given component. Mainly, the data sheet is like instruction manual created by the manufacturer of that component. So the manufacturer writes each and every instruction in those data sheets about how we can use that component and how the pins of that component, be it resistor or capacitor or any IC, how the pins of any component are supposed to be operated. What are the voltage levels of those pins? What should be the current levels of those pins, right? And how we can create the footprint of that component if we want to add that component in our schematic and PCB layout, and if we want to use them. So the datasheet basically contains all the instructions and all the details of the components that we are gonna use in our schematic or in our PCB layout, right? So now we will see all these details of the course one by one. So first of all, you can see that this is basically the basic GUI of EasyEDA software. It contains the project folder, the design manager, the commonly libraries. The project folder basically contains two types of informations. It contains the all projects informations and it contains the opened project informations. EasyEDA is a software basically which can save your projects online, right? So let's say if a person have worked on EasyEDA for a longer period of time and he has worked on multiple projects, so all of his projects will be saved in this all projects window. And let's say the person is currently working on only 2 or 3 projects out of his many projects, then those two or three projects that the person is currently working on will be opened in this will be placed in this open projects tab, right? So this explains the project folder. Next is the design manager. It contains multiple options of verifying the designs and testing the design. It contains the design rule manager that checks the not connected pins or multiple net labels or anything. So it basically validates our schematic or our design, right? So next is the commonly used libraries. It basically contains basic voltages, basic grounds like analog grounds, digital grounds. Basic voltages can be plus 12 volts, plus 5 volts, plus 3.3 volts. And it contains basic footprints and schematic components of the resistors, capacitors, inductors, everything, right? So if we just want to make a design and we don't want to make its PCB, we just use commonly used libraries and place the components from that and export that design in PDF and show the person that this is the schematic that we want. This design, the parts used from these libraries cannot be located in like real life. I mean, they don't have any part number or any identity through which we can locate those components in any of the real life components. Next is the library. This is the main tool of the EasyEDA. Through library, we search each and every components in the LCSC library or DGKey library or any user contributed library. And next is the LCSC part. Basically, if we click on that, it will open the LCSC website. We will see in future that what is the LCSC website and how is it useful. Next is the JLC PCB icon. Clicking this icon will open the JLC PCB website. We will also see this in future that what is the purpose of the website of JLC PCB. Here you can see the schematic which is currently opened in the EasyEDA software. So this tab is the schematic tab of the EasyEDA software. In the schematic tab you can see the further details of the schematic about what page number this is and what is the name of the schematic, when was it created and everything. That's the next tab is of the PCB layout, and clicking on that tab will open up the PCB layout of the current schematic. it will basically show us the board area and how these connectors and everything is placed in the PCB layout. So this is the wiring tool of the EasyEDA software, in which we have the multiple options of net labels, connections, not connections, like normally open connections or don't connect tool. Next is the drawing tool of the EasyEDA software, which contains also multiple options of how we can draw multiple circles or waves or different type of texts or rectangles in the schematic diagram. So all of these tools are very helpful in designing the basic schematic. Also here we can see that this is the window which shows the pointer position continuously. As you move the pointer in the EasyEDA software, the X and Y locations are basically changed according to the position of the pointer. And you can also see some canvas properties, and if you select any of the component or any of the label, then you can easily see its properties and change its properties from this a particular window. Next is the schematic diagram in the EasyEDA software. Here you can see a simple schematic diagram in which we have different types of net labels, and we have the schematic components. We have their designators, like this is U1, it's the designator of this IC. This is D1, it's the designator of this Zener diode. Here is the R6 and R7. These are the designators of 53.6 kilo resistor and 10.2 kilo resistor respectively. You can see the designator P2, which is of this connector. Now in EasyEDA, if we want to create a schematic diagram, then first we place all the components that are required to be connected with each other in the schematic capture. After that, if we want to connect any of the two components, then we have two options to connect those components. The first one is connecting them with these green lines called the wires, and the other option is using the facility of net labels. Here you can see that the pin 1 is connected with a net label called ground. Also this pin 1 of H1 connector is connected with the net label ground. So if both of them are ground, it means that they both are physically connected with each other. Similarly, here this is ground as well, this is also the ground. It means 1, 2, 3, 4, 5. These 5 grounds are physically connected with each other because their net label is having the same name, right? Next we will see the traces and poly. These both are the parts of the PCB layout. So here you can see a simple PCB layout of the previously shown schematic diagram. Now these here are the red traces. These are the top layer traces, and you can see the polys as well. This whole rectangular thing is known as the poly. Once we start the course, we will see the detailed difference between the traces and poly. Basically, if any of the signal is supposed to be connected in the PCB layout, it is connected through the traces. But if we need to route the board, which is of power board, that is supposed to carry a lot of current and a lot of voltage, then we try the poly technique in the PCB layout. So we will see the difference between the traces and poly in the course in detail. Next is basically a PCB. It's a picture of a simple PCB, how the PCB looks, how some of the components in this PCB are SMD, that is they are mounted on the surface of the PCB, and how some of the components are through hole, right? They are mounted on the top of the PCB, and their pins are going right below at the bottom of the PCB. So looking at this PCB, we can say that this one is the SMD component, this one is also SMD. Here the U4 is the SMD component, U5, U2, R3, C7, C3, X1. All of them are SMD components, but the H1 connector here you can see is the through-hole component. Also, another point which is required to be noted in this PCB, that there are some mounting holes available in this PCB. These are basically kept if we want to mount the PCB in some mechanical or in some other place. So basically M1, M2, M3 or M4 screws are mounted through these holes, right? And the diameter of hole is kept according to the screws that we are supposed to use in the PCB. We make sure that the diameter is so that we make sure basically that the diameter is according to the hole size of the screws. So this is the main difference between the through hole and SMD components. You can see this 2-pin connector. It is mounted on top of the PCB and it is coming right through the PCB to the bottom layer, right? So this basically is the through hole component. Also you can see that this IC here, it is placed on the top layer of the PCB and it's not going to the bottom layer. So this IC here will be the SMD component and this connector will be the through hole because it is mounted on the top layer and it is going right to the bottom layer. Also the main difference between through hole and SMD component is that the through hole components are comparatively larger in size and they have also less price. When it comes to price, their price is comparatively lower than the SMD components. And the third difference between them is that through the rating of through hole components, the voltage and current rating of through hole components is comparatively larger than the SMD components. And the SMD components are normally very expensive. Their rating is comparatively very low, but their size is very small. So in the designs where we have the size constraints, for example, some of the PCB is required to fit in some enclosure or in mechanical, then we select the SMD components. But if we don't have the size constraint, we just select the through hole components and use them as required. Next is the Gerber files. Gerber files are basically for the fabricator of the PCB, right? After the completion of schematic diagram and PCB layout, we create these Gerber files and send to the fabricator. These files are according to the layers that we have used in the PCB. For example, you can see in this example these Gerber files are for the top layer. These are also for the top layer, and all of these three files and this one is for the bottom layer of the PCB. Simply here is one Gerber files which is for the board outline of the PCB, right? These files are understood by the CNC machine, which basically creates pads and holes and everything for the through hole and assembly components. So these are understood by the CNC machine that is used by the fabricator to create the PCB from scratch, Next is the bill of material, which is also called the BOM or BOM or BOM. So it basically contains the names of the components that we have used in the schematic and PCB, their designators and their footprint and quantities, right? For example, in given example of bill of material, you can see that here Matic Micro BEC 5 volt is used in quantity 2 in the given design, and the designators of these two modules in the design is U7 and U8. Also here you can see that 10 kilo ohm resistors in the design are of quantity 3, and their 3 quantity is as the designators of R1, R2 and R4. So bill of material basically contains each and every component that has been used in the schematic and the PCB layout. Next, we will also learn about the layers of the PCB. We have already discussed that complex designs have normally multi-layers and the simple designs have normally 1 or 2 layers. It is to be remembered that PCB layers are always of even number except for the single layer PCB. Single layer PCB is of 1 layer, so number 1 is odd, right? Apart from single layer boards, the 2 layer, 4 layer, 6 layer, and it goes up to 32 layers. All of the PCB layers are of even number. There never comes a time, or there isn't any software that creates 3 layered board or 5 layered board or 7 or 9 layered board. So they are always of even number. Next, in the introduction, we will learn how the data sheets of any components work, how we can get the suitable information from the manufacturer's manual of that component. We will also learn about the custom components. For example, we need to place any component in the schematic and it has no schematic component, right? Then we will learn how we can create ourselves the schematic component or PCB footprint of that component in the EasyEDA. We will learn about the custom footprint creation, and that's all for the introduction of this course.